Good afternoon to all of you. Is my voice is audible to all of you? Is my voice is audible to all of you? Is my voice is audible to all of you? My voice is audible to all of you? Hello? Okay, fine. Let's start. Okay, so today we are going to solve some of the important classroom problem, and on this problem you will get an idea how you can solve this problem. Okay, fine. Thank you all. So now this is the first problem to you. So I already have solved this problem, but many of the students, they have asked, so they have the doubt on this problem. So let's solve this problem. I am keeping some time for you so that you can able to read this problem. Suppose I am keeping it some time for you. 1 minute time I am keeping for you. So try to read this problem and solve it. Thank you. Good afternoon to all of you. So 1 minute time is there. Read and try to solve this one in your class note. One minute there. Good afternoon to all of you. Try to solve this problem. Okay, fine. Let's start this problem. So it is saying in this figure, an U2 having, let me choose the color. Okay, I have to choose this. Okay, so it is saying in this one, if the cross sectional of the U2 manometer has given you 5 millimeter and 5 millimeter, and it is filled with mercury, of specific gravity is given you 13.6. The specific gravity is given 13.6, and it is filled up to a height of 20 centimeter from each limb. Okay, now it is saying what in next, this is case 2 part. In this case 2, it is saying a 5 centimeter cube of water has been added. Okay, so a 5 centimeter cube of water has been added, and to the right limb, it is added to the right limb. So it is asking what is the new height of mercury in the left limb. Okay, so this is the case 1. So what is happening in case 2? Some water has been added into the right limb. This is left limb, this one is called left limb, and this one is called right limb. Okay, so in right limb some amount of water has been added, some volume of water has been added. So what will happen? As water will come into this right limb, so there is a pressure will be created by this water at this interface. Due to what will happen, this mercury level from the right limb will try to fall, and there will some gain in mercury level at the left limb part. Okay, as the mercury is fluid is incompressible nature, so whatever may be the fall in mercury in the right limb, the same amount of mercury will be gain in the right limb. So if I draw the second figure, so suppose I'm drawing the second figure, so let me draw this one. So this is the second case in which, so let me draw. Okay, so what will happen? So here the water has been come. Okay, suppose Initial level of mercury was this one. Okay, initial level of mercury was this one. Initial level of mercury was this one. So what will happen after some water has been added? So water will come up to this much. So water has been added to this one. So what will happen? There is a fall in mercury. Suppose this much amount of mercury has been fall, and suppose what will happen? Same amount of mercury will be gain in the left limb. This is the mercury gain in the right limb. So in this right limb, this is the right limb. Okay, this is in this right limb. Whatever the mercury will be fall, that space will be occupied by what? That space will be occupied by the water. So in this water will come. So in this water will come. Okay, so here complete water will come. Okay, now what is this one? This one is mercury one. So this one will be mercury. Okay, okay, this one is mercury. This one is mercury. Okay, up to this one. So this is the mercury, and this is the height gained by this mercury. This is the height gain. Suppose this height is, I am taking one as this one h1. What is the fall of mercury? This is the fall. Okay, this one is called, this is called h2. Okay, this is the fall. Okay, how what amount there is the same, how much amount will be fall of mercury in the right limb? The same amount will be gain in the right limb, because of the fluid is incompressible in nature. Okay, so we have to find out this new height. We have to find out this new height. So we have to measure this new height. What is this new height? This new height will be 20. So this is the new height. So this new height we have to measure. What is this new height? This new height will be equal to, so this new height will be equal to, this is 20 plus this is h1. So what we have to find out this h1. What is the gain in this mercury level in the left limb? What is the gain? Or how much gain has been occurred in the left limb? So suppose this is the height of the water which has been occupied when there is, we poured some volume of the water we have poured into this right limb. This is the height of the water, suppose y. So how can we find out this y? Okay, so head of water we can find out this. Okay, so this head of water, so this head of water in the right limb, y will be equal to, okay, are you able to this voice is audible to all of you? Okay, so this head of water y will be what? This is equal to volume of water added divided by the cross sectional area of the manometer. Okay, cross sectional area of the U-tube manometer A. Okay, so this is what? This is my y. Okay, this is my y. Okay, this is my y. So now we have to find out the pressure. Suppose I am taking this one as my reference axis. Okay, suppose this one I am taking as my reference axis. Suppose this one I am taking as my reference axis. Let me draw again this figure so that you will get a clear idea. Suppose, so this is my U-tube manometer. Okay, so what will happen? The mercury level has been, so this is the initial level of this mercury was, this was initial level. So there is a fall in mercury, and there is a, this much the gain of mercury, and in this what will happen? In this is the depression. So in this depression what will happen? The water will come. So the water will come up to this height. Okay, and this is the mercury level. Okay, and this height is given to you as, this was 20 centimeter. So we have to find out this height h1, and this is new height. This is my new height. We have to find out this new height. Okay, so I have to choose a reference axis. So this is my, reference. This is my x, my y. Okay, so I can write down this manometer equilibrium equation. Now I am writing it down, this manometer equilibrium equation. So pressure in left limb will be equal to pressure in right limb. Okay, now this is my left limb, this is left limb, and this one is my right limb. So start pressure at X, I can write down, this is mercury, density of the mercury into this is G, and what is this height, what is this height? Okay, this height is how much? Suppose this height I chosen have, this one is H1. Suppose this total height I am choosing, this one is this height, total height. Suppose this total height, this is suppose H, capital H, small h. Okay, so this is rho G into H, because entire height will be mercury will be there. Okay, so density of the mercury into G into this H. I reach that point. Now it will be equal to the pressure in right limb. What is the pressure will write in? Simply water will be there. Density of the water. What is this height? This height will be Y. Okay. Density of water G into this Y. Okay. So from here I can find out this total height H will be equal to, this is density of the water into Y divided by, this is how much? Density of the mercury. Okay, density of the mercury. So now this H I can write it down, this is Y divided by density of the mercury divided by, this is density of the water. So this Y will be equal to specific gravity of the mercury. Now again I can simplify this formula. What I got, Y will be what? This volume of the water added divided by cross sectional area of the manometer. Okay, so I can write down, this is B divided by, this is A into, this is specific gravity of the mercury. So now I can find out one formula. This H will be equal to this volume of the water added into this cross sectional right limb or this manometer into specific gravity of the manometer. So I can use this formula to calculate this height H. What is this H? This H will be equal to nothing but one. It will be equal to, this is H2. So this height will be, this is H2, the fall, and the gain will be, this one is H1. The gain will be, this one is H1. So H will be equal to what? H1 plus this is H2. Suppose this is my equation 1. Okay, and this is my equation 2. So now I can find out, use the volumetric balance equation. Now I have to use the volumetric balance equation. What is this volumetric balance equation? Whatever the volume of the fluid has been fall in this right limb, the same amount will be gain in the left limb. Okay, because the fluid is incompressible nature. Press करो सेतिकी सेपट को जीवो. Okay, so volume gain I can write down, the volume fall will be equal to the volume gain. Okay, what is the volume of the fall? This is A into, this is H1, this is H2. What is the volume gain? This is A into this H1. So A is constant. Both manometer cross section in right limb and left limb are constant. So I can find out this H1 will be equal to H2. Okay, this H2. This is equation 3. Okay, so now I can put this one in this equation 1. What I can get, because I know this H will be equal to H1 plus H2. So I can find out, this is 2H1 will be, now I have to find out this H1 will be equal to, this is simply H by 2. Okay, so in this form of H, I can put what? H1 by 2. Okay, H will be equal to 2 times 1. I can put. Now you solve, you will get your answer. Now if you solve this one, so we got this height will be equal to, this H is how much? This V. Now okay, अभी बफरिंग का इशू हो रहा है क्या? So fine. So just tell me whether the internet connection is okay or not. Otherwise we have to stop right over here. Is it Hello. 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 Okay. So let's do. If there is any problem, we'll stop there. From tomorrow, I will have some good internet connection. Then I will proceed. So we can find out. So here this h I can put this h I already found out. This is 2 times h1. So 2 times h1 will be equal to v by a into specific gravity of the manometric fluid. Okay, so now this h1 I can find out. This h1 will be equal to, this is v divided by, this is 2 into a into specific gravity of the manometric fluid. Now you put all this value, you find out this h1. Now you put all this value and find out this h1. So v will be how much given to you? This v is given how much? This v is given to how much? This is 5 centimeter cube is given. This is 5 centimeter cube, and this area of the limb is given how much? This is 0.5 millimeter is given, so 0.5 centimeter square. Okay, into specific gravity manometer 13.6. Okay, 13.6. Again you reload this one, this video. Again you reload. Is it okay now? Still buffering. Okay. So is it okay now? So is it okay now? Otherwise you stop today. Tomorrow I will start. Is it okay? Buffering. I think it is okay now. Okay, still buffering. Let's stop today here. Tomorrow I will let you know if the internet connection is good here. I'm trying. If it is not possible, tomorrow we will start. Is it buffering now also? Okay. Let's stop today. Is it buffering now also? No. Hello. Okay, we'll stop today. I think it will not. I think it is good now. Right now, here it is showing good. Just put, if it is okay, just put a thumbs up, otherwise we'll stop here. Otherwise we'll stop here. Please put it is okay right now. Is it okay right now? Is it okay right now? Is it okay? Okay. Okay, let's proceed. This is Corona time. All are in problem, so I think you understand the situation. So H1 you calculate here. H1. So H1 is how much you calculate here. So if you put all these values, the H1 is coming out to be how much? This is coming out to be 0.735 centimeter. Okay, from tomorrow onwards I think the internet problem will be sorted out. Okay, so 0.735 centimeter. Okay, 0.735. So what is the new height? New height will be how much? The new height will be, this will be equal to 20 plus 0.735. So what is this? Is 20.735 centimeter. So this is my new height. So this is my 20.735 centimeter. Okay, so now you'll go to the next problem. You see this problem and try to solve. Read this problem for 1 minute, then we'll go to the next problem. Read this problem for 1 minute. Read this problem for 1 minute. Let's solve this problem. Okay, let's solve this problem. So this is the case, it is given. So it is given. So this is one chamber. Okay, and this is one chamber. Okay, in which it is connected with a U2 manometer. And it is connected with a U2 manometer. Is connected. Okay, so here is some pressure measuring device are connected. So here is some pressure measuring device are connected. Okay, suppose the mercury has been, the level of the mercury, it is given like this. The level of the mercury, it is given like this. Okay, what is this height? This height, it has been given to you 0.5 meter. So this height is 0.5 meter. And here in this chamber, what is, air is there, and here it is oil is there. Okay, it is air is there in this chamber, and here this is oil, and this chamber is water is there. So it is asking to find out the pressure at this point, L point, and this M point. We have to find out the pressure at L and M point. Okay, so here is vaporized mercury will be there. This one is closed. This U2 manometer has been closed right over here. Okay, the U2 manometer has been closed right over here. Here is the mercury vapor will be there. Mercury vapor will be there. Okay, the mercury is vaporized state. Okay, so I'm choosing here 2 points. Suppose I'm drawing a reference axis. This is, and choosing this point as A, and this point will be as B. Okay, so as there is air in this chamber, so air exerts uniform pressure is throughout. Air exerts uniform pressure throughout. Whatever the pressure at this point B, what the pressure will be at this point L. Okay, at this point L, because air will be exert uniform pressure. So I can write the pressure at point B will be equal to pressure at point L, because air is there. So what is pressure at point B? Pressure at point B will be equal to pressure at point A. Okay, so if I can measure the pressure at point A, then I can find out the pressure at point this L. It is very easy now. It is looking like very big problem. So now you can find out this pressure at point A. What is the pressure at point A? If the pressure exerted by this mercury vapor, if we neglect that one, then we can find out. And mercury vapor will the pressure will be very small. Okay, so it has been assumed. Okay, the pressure due to this mercury vapor, the mercury vapor is negligible. The pressure due to this mercury vapor is negligible. Okay, so now pressure at point A, I can find out this is density of the mercury into G into this is 0.5 meter. Okay, if this mercury vapor pressure is negligible, then simply I can find out pressure at point A. What is this I'm getting? This is 13,600 and this is 9.81 and this is 0.5. How much this is coming out to be? This is coming out to be 66,708.8. This is Pascal. Now if you convert into this kilopascal, this pressure at point A, it is coming out to be 66.70 kilopascal. This is the pressure at point A. So that is nothing but only pressure at point L. That is the pressure at point L. Okay, that is the pressure at point L. So now we have to find out what is the pressure at point M. Okay, what is the pressure at point M? So this pressure we are finding. What is the question? You see in this question, what is he asking? So in this question it is asking, where is that question gone? Where is that question? Let me find out. So in this problem, it is asking the pressure at this point is given to you. Okay, so finding the gauge with a value of the L and M, if the local atmospheric pressure is given to you as 755 mercury. So this is given 755 millimeter mercury is given to us. Okay, so now we have to find out what is the local atmospheric pressure. Find the gauge reading at this L and M. Okay, so already we find out the pressure at point A. Okay, the pressure at point A, how much that came? Okay, let me go solve this one. The pressure at point A, I found out what is the pressure at point A. Pressure at point A, I find out this is 66.708. This is kilopascal. This is the pressure at point A I found out. Okay, so now what is the atmospheric pressure is given to you? The local atmospheric by barometer which you measure, that is given out to be 755 mm of, that is mercury is given to us, 755 mm of mercury. Okay, so now atmospheric pressure you find out, because this is given in the form of head is given to you. Okay, now you convert into the pressure form. So that is density of this mercury, okay, G into this is nothing but given, and this is head form. Okay, this head of the mercury is given to you. So this is head of the mercury. So density of the mercury, this is 13,600 and this is 9.81, and this head of the mercury is given 755. So in order to convert into this meter, we have to divide by 1000. What is this atmospheric pressure? Local atmospheric pressure, this is 100.729. This is kilopascal. Okay, this is atmospheric pressure. Okay, this is now this pressure, whatever the pressure we got, this pressure at point A, that is nothing but this is absolute, and this total pressure we got. This is total pressure at point A. Now we know this absolute pressure at point A will be equal to gauge pressure at point A plus this local atmospheric pressure. Okay, and we found out this total pressure is how much? 66.708. Okay, and gauge pressure we have to find out at this point A. What is the local atmospheric pressure is found out? This is 100.729. So what is this gauge pressure at this point A? So gauge pressure at this point A will be equal to minus 34 kilopascal. This is the answer. Minus 34 kilopascal will be equal to minus 34 kilopascal. That is the gauge pressure at point A. Okay. Now we have to find out what is the pressure at point M. We have to find out. Okay. So here it is saying we have to find out what the pressure at. We found out this pressure. So we found out this pressure. We found out at L point. Now I have to find out the pressure at point M. Okay. So now I have to find out the pressure at this point, M point. How we can find out? See, we found out the pressure at point this. Found out the pressure at this point. We found out. Okay. So now at this point, pressure at this point we found out. Now can you able to find out this pressure at point A? Because simply you have to add this one, na? Oil pressure, water pressure, and pressure at point A. That will be your total pressure. Do it. Do it, simply do it. So now see, if you find out the pressure at point M will be what? Pressure at point M will be what? Pressure at point M will be pressure at point A plus the pressure due to this 1.2 meter head of the oil plus the pressure due to 1.5 minus 0.1 you have to do that head of the water. That head of the water simply you have to do at this pressure point M. I think it is clear. Pressure at point M, I'm again repeating. So the pressure at this point. So what is the pressure acting at this point? Pressure at this point will be how much? This is pressure at this point PA plus the pressure will be pressure exerted by this 1.2 meter head of the oil plus the pressure exerted by this 1.5 minus 0.1, that is the head of the water. Okay. So now simply I am doing that one. Pressure at point M will be equal to, so this is this pressure at this point A, pressure at this point A plus the pressure, the oil pressure plus this water pressure. Okay. So here we are measuring this total pressure. We are measuring this what? We are measuring directly. I am finding out the gauge pressure. Okay, gauge pressure. So what is this pressure at point A? Pressure at point A gauge pressure is minus 34 plus the oil pressure will be density of the oil into G into this is height of the oil plus density of the water G into this height of the water. So this is minus 34 plus density of the oil is how much? Because 0.85 is given you as specific gravity of the oil, 0.85. So this is 850 into this is 9.81 into height of the oil is how much? This is 1.2 is given to you plus density of the water is how much? This is 1000 kg per meter cube into this is 9.81 into this height of the water, this is 1.5 minus 0.1 you have to do. Okay. Now this is in kilopascal. So in order to convert into this kilopascal, we have to divide it by 1000. We have to divide it by 1000. Okay. So now if you solve this one, this is coming out to be minus 10.26 kilopascal. So this is the pressure at point M in the form of gauge. Okay, in the form of gauge. Minus 10.26 pascal, which is a vacuum pressure. The pressure at this point M and L are both vacuum pressure. What is this pressure at point M? So we got this pressure at point M will be equal to, this is how much? This pressure at point M is how much? This is minus 10.26 and this pressure at point L will be minus 34 kilopascal. Okay, this is we found out. Okay, now we'll go to the next question. So this is the question you see. So what happened? So this is the question. So it is saying a tank of This question has been asked by one student yesterday. A tank is 1.8 meter deep and square length of 4.5 meter is given to you at the top. Okay, and length is the top length is given 4.5 meter and the bottom length is given 3 meter, and the four sides are plain and each one has trapezoid shape. The tank is completely full of oil. Completely, so it is saying this is the tank is completely full of oil. So now it is asking, the tank is completely full of oil. So this is completely full of oil, and the oil weight is given density is given 936 kg per meter cube. What is the resultant pressure on each side? Okay, what is the resultant pressure each side? Okay, so try to solve this question. Yesterday one student has been asked to me, try to solve this question. So let me solve. So it is saying next problem, this solution. So it is saying, so a tank of trapezoid nature. So if you draw the 3D diagram, trying to draw for you. So I'm trying to draw it is. So it is look like this. Okay. So what is saying? This height is given you as 1.8 meter. This height is given 1.8 meter. Okay. And this bottom length is given you as this is 3 meter. And this top is given you as this is 4.5 meter. Okay. So now it is asking to find out the pressure on each side. What is the resultant pressure? Suppose I am drawing one of this side. I think you can imagine this side also. This is inclined side. Okay, like this inclined side will be there. Okay, so I think you can imagine this one. So this is side. So I'm drawing the one of the surface. So this is my top. Okay, so suppose this is my one side I'm drawing. This is very easy question, and this is my 4.5 meter. Okay, this is my 4.5 meter, and this is my how much? This height is 3.3 meter. Okay, now this is what is the height is given. This height is perpendicular height. This is the perpendicular height from the oil, free surface of the oil. The perpendicular height from the free surface of the oil. Okay, now we have to find out what is the hydrostatic force of the oil. What is the hydrostatic force of the oil? This is density of the oil into G into this is YC into this A. What is this area? This is projected area. Okay, this is projected area. So YC you can find out, there is no problem. YC always measure from the free surface to the centroid of this area. You measure the vertically, not inclinedly. Now you can just imagine here. See this side. Okay, this side. If you find out the area of this one. Okay, this is trapezoid. This length is. This is 4.5 meter and this one is 3 meter. It looks like. So if you find out this projected area, what is this projected area? You have to find out this height. You have to measure this height. Okay, this height is given to you. This is 1.8. Okay, what is this height? What is the distance? This distance will be equal to, this is 4.5 minus 3 divided by 2. Okay, 4.5 minus 3 divided by 2. How much it is coming out to be? This is 0.9 meter. Okay, this height will be 0.9 meter, and this is given you with 1.8 meter. Can you able to find out this height? So this is square root of 1.8 square plus this is 0.9 square. How much it is coming? It is coming 1.95. So this height we called this height we found, this is 1.95. Okay, now what is that projected area? What is the projected area? Trapezoid, this is a plus b by 2 into this is h. A plus b by 2 into h. What is this a? What is this a? This is 4.5 plus this one is 3. Okay, divided by 2. And here the h will be this inclined distance, because the distance in between them is now 1.95. This is 1.95. What is this projected area we are getting? This is 7 point. This is 7 point a plus b by 2 into this is, so this 7.3125 meter square. Now we have to find out this yc. Okay, what is this yc? Yc, if you find out, this is measured from this free surface perpendicularly from the free surface. Suppose this is my a and this is my b and this is my h. What is this yc? Trapezoid centroid. This is a, you are measuring from this side, so a plus 2 times of the opposite sides. This is 2b divided by this is a plus b into this is how much? H by 3. Simply you have to put this is how much? So this is 4.5 plus this is 2 into 3 divided by this is 4.5 plus 3. Okay, into this is how much? Into this is 1.8 by 3. So how much this is yc is coming out to be? This yc is coming out to be 0.84 meter. 0.84. So the projected area is coming out to 7.3125 and this yc. Now can you able to find out the hydrostatic force on each surface? So now if you find out the hydrostatic force by the oil on each surface, the density of the oil is how much? Density of the density is given 936 kg per meter cube. So density into G into this is yc, this is area projected. So density is now this is 936 kg per meter cube into this is 9.81 and yc is how much? 0.84 into this projected area is how much? This is 7.3125. 7.31. How much this you calculate, how much you are getting? And this is asking kg force. If you see this option R, it is asking in kg force. So it is asking in kg force. So we are finding out in Newton. Okay, so we have to divide it by what? Divide it by 9.81. So how much this kg force it is coming out? This is 5749.38 kg force. 5749.38 kg force. This is the hydrostatic force by oil. So this is the hydrostatic force by oil. What is the answer for this one? Correct answer for this one. The correct answer will be this is 5749 approximately, option A. So actually correct answer will be this is 5749.38. This is kg force. Okay, the correct answer will be option A. Fight to survive. Yes, correct. Where exactly you are saying the answer. Thanks. So now we are going to the next question. Initially you disturbed for some time, so sorry for that one. This is the next question. You read this question. So as ocean, this is I'm setting the time for you. So read this question carefully. The ocean linear 240 meter long and 20 meter wide, which displays 654 meganewton of seawater. Okay, density of the seawater is given to you 1025 kg per meter cube. The second moment of inertia of water plane about the 4, and this is acting about this plan. Okay, it is saying the moment of inertia is given is 2/3 of the circumscribing rectangle. Okay, the position of the center of buoyancy is 2.3 meter below the center of gravity. Okay, so what is saying, you have to find out what? You have to find out the metacentric height. Okay, we have to find out this GM. What is the metacentric height? So let me solve this one. So it is saying a ocean linear like this one. Okay, this is actually submerged inside this water. Okay, submerged inside this water, and it has a length. This is given you as, this is 240 meter is given to you, and this width is given you, this is 24 meter. Okay, and we have to find out the metacentric height. Okay, suppose this is M, and this point is center of gravity, and this point is center of buoyancy. So you have to find out this GM. So GM will be what? GM will be equal to, this is BM minus this is BG. Okay, BM minus BG. What is this BM? This is nothing but minimum moment of inertia of the top view. If you see from its top, it is just like a rectangle. Okay, if you see it from this top, this is the minimum moment of inertia. So this is y, this is x axis. Okay, this is y axis. So you have to choose the minimum moment of inertia of x, and this is y. Okay, so I minimum divided by how much volume has been submerged. Okay, minus this BG will be what? BG. Okay, and it is said that, you see that question, it is said clearly, it is saying that position of the center of buoyancy is 2.3 meter below the center of gravity. Okay, so position of the center of buoyancy, that is nothing but BG only, nothing but BG only. So BG, it is saying the center of buoyancy is how much below? 2.30. So if you see, this is my position of the center of buoyancy, and this is center of gravity. Is saying this one is 2.30 meter. Okay, so BG nothing but is saying clearly this is 2.30 meter. So only this thing given to, only you have to find out this BM. Okay, and this minimum moment of inertia is saying, first of all, you find out this minimum moment of inertia. It is saying this is 2/3 of the rectangle area. Okay, so you tell me which one will be, suppose this will be your, this will be, see from the plan, so this is 24 meter, and this will be your 240 meter. Okay, so minimum moment of inertia is how we will found out. This is BHQ by 12. So this is 240 into this is 24Q divided by this is 12. This is the minimum moment of inertia. Okay, so now this is 2/3 of this one. This is 240 into this is 24Q divided by this is 12. Okay, so now how much volume has been submerged, we have to find out. This is we found out. Suppose this is equation 1. This is equation 1. Okay, so this is equation 1. So now you have to find out how much volume has been displaced or how much volume has been submerged. It has been said that the weight of the fluid displacement, how much? The weight of the fluid displaced, that is given you as 654 meganewton. 654 meganewton is given to you. So now we know that this volume of displaced will be equal to weight of the fluid displaced divided by density of the sea water into this is G. Okay, into this is G. So now I can find out this volume of the fluid displaced. So weight of the fluid displaced is what? This is 654 meganewton. 654 into this is 10 to the 6 Newton. 10 to the 6 Newton. Density of the sea water, this is 1025 into this is 9.81. Okay, so now this is equation 2. Can you able to find out this BM? So BM will be what? This BM will be equal to, this is I minimum divided by this is how much volume has been displaced or submerged. So this is I minimum, what, this is 2/3 into this is 240 into 24 q by this is 12 divided by this is 654 into 10 to the power 6 divided by this one will be 1 this is 1025, okay, into this is 9.81. Can you able to solve this one? If you can solve, they can find out. So this BM is coming out to be how much? This is 2.833, this is meter, okay. This BM is 2.833 meter. Now we have to find out this GM, metacentric height. This is nothing but this BM minus this is BG. So this is 2.833 minus BG is how much given? This is 2.3. Okay, this is 2.3. So now how much? This is 0.533 meter. Now it is asking in centimeter. So it is asking in centimeter. This is centimeter. This is nothing but 53.3 centimeter. Okay, this metacentric, it is coming positive. So this is a stable equilibrium. Okay, so this is a stable equilibrium condition. Now what is the answer of this question? Okay, what is the answer of this question? So the answer of this question is which one? Approximately the answer we got it. The answer we got is 53.3 centimeter. Okay, the answer we got, it is 53.3 centimeter. Okay, the correct answer will be this 53. Option B. Correct option will be option B. Yes, yes. Pradyumna Kumar is correct. Fight to survive. Answer B. Yes, correct. Now we have to go to the next question. So this is our next question. This is next question, you see. So it is saying here the gate is there. Okay, here is the gate, and this is the upstream side of this one. This is the upstream side of this gate. Okay, so this is the upstream side of the gate is there, and upstream side there is a reservoir will be there, and the water is actually stagnant by this reservoir by using this gate. Okay, and it is actually balanced by a weight. This is a weight which is suspended by a string, and the string is attached to the gate. So this is a gate. Okay, now we have to find out what is this height, what should be this height. Okay, what should be this height, we have to find out, so that the gate will be just about to fall. Okay, just about to fall, we have to find out. And this point is called as, this point is called a hinge point. Okay, this point, A point, is called as hinge point. So what we have to do, you have to write the moment equilibrium equation about this point A. You have to just write down the moment equilibrium equation about this point A. Okay, now if you draw the pressure distribution curve, how it will act? Hydrostatic pressure distribution. This is the pressure distribution curve. Okay, this is the pressure distribution curve. This is the hydrostatic pressure distribution. The pressure will act like this. Okay, and where somewhere here the total resultant of this pressure distribution curve will act. This is called hydrostatic pressure. Somewhere here the resultant of the pressure distribution curve will occur. Okay, so now suppose this distance, suppose this I'm taking h, and this one is x. Okay, and this distance is given you. Okay, this is, suppose this is the tensile force in the string. Okay, so moment equilibrium equation about this point A, I can write down this hydrostatic force into this x minus this tension into this distance is AB. AB is how much? 6 meter. This is equation 1. Now you have to solve it. Okay, now you have to solve it. Let's solve this question. Let's solve this question. Okay, Let's solve this question. Try to solve this question along with me. So this is the case is given to you. So this is the water surface is given to you. Okay, and here is the gate will be there. So here is a gate will be there. Okay, this gate, and there is a string is there, and this string is there, and string is attached to a pulley. There is a pulley will be there, and through this pulley a weight will be suspended. Okay, this weight will be suspended. So what will happen? This is the base of this one. This gate, this is the base of this gate. Okay, and this point is taken, this is the hinge point. Suppose this I am taking, this is point O. Suppose for my understanding this is point O, and this point I am taking, this point is a point. Okay, this point is A. So somewhere here the hydrostatic force will act, somewhere here the hydrostatic force will act. Okay, and suppose this distance, this perpendicular distance, okay, this perpendicular distance, because the hydrostatic force will act perpendicular to this one. Here is this one. This hydrostatic force will act perpendicular to this. So this hydrostatic force, it will act perpendicular to the contact surface. So this is like perpendicular to the contact surface. So let this x distance will be x. Okay, now this is there as the weight will act downward, in this string will the tensile force will act. So this is my tensile force T. Okay, and this is length is given is how much? This 6 meter is length is given. This gate length is 6 meter. Width is how much? 2 meter is given to you. So now I can write down the moment equilibrium equation about this point will be equal to 0 for equilibrium condition. I am writing down. So this hydrostatic force, it will create a moment clockwise manner about this point O. So this hydrostatic force into this x, and this is positive clockwise, minus this tensile force into this how much? 6 meter will be equal to 0. Okay, so I can write down this hydrostatic force into this x will be equal to 6 into T. This equation 1. Now I have to find out this hydrostatic force. Now I have to find out how can find out hydrostatic force will be equal to, very simple, just you consider within 2 minutes. If you practice, because I am making you understand, that's why taking time. If you practice within 1 minute you can solve this. So this is rho g into this is yc into a. Okay, now what is this projected area? Because here is the water is there na, so we have to take the projected area which is contact with this fluid. The projected area which is contact with this fluid. What is this projected area? So suppose this is the depth of the water, h is there. So this is the depth of the water, h. So this yc will be equal to, this is h by 2. There is no problem, yc will be. Now we have to find out this projected area. This projected area will be how much? This projected area which is contact with this fluid, that is nothing but will be equal to this OA, okay, into this 2 meter width. If you see from this side, it will look like this. So this is my OA, and this is my 2 meter. Okay, this is my 2 meter. This is the projected area. Okay, what is this OA? Because this angle is given to us, it is mentioned because this angle is given 60 degree. Okay, this angle is given as you 60 degree. Okay, and this height is given to us. This height is h. Okay, so sine 60 will be equal to this p by OA. This is OA. Sine 60 will be equal to h by OA. Okay, sine 60 degree will be equal to, this is h by this is OA. So OA will be how much? OA will be equal to h by sine 60 degree. H by sine 60 degree. Now we can find out this project area or not. Can you able to find out this project area? So this hydrostatic force is coming out to be density of the water into G into yc equal h by 2. This area will be equal to, this is OA into 2. So this is h by sine 60 into this is 2 meter. Okay, into this is 2 meter. So this is in Newton. In order to convert into kilonewton, we have to divide it by 1000. So how much we are getting this one? How much we are getting this one? So we are getting this one as 11.327 a square. We got our hydrostatic force. Now I have to find out this x. Now I have to find out this x. We have to find out what is this x. X is how much? You tell me. X is what? This point is nothing but is called center of pressure, where the total hydrostatic force will act. That point is called as center of pressure. Okay, center of pressure is what? The center of the pressure distribution curve. If you draw the pressure distribution curve, this is the pressure distribution curve. Okay, so this is the pressure distribution curve. This is nothing but center of the pressure distribution curve. What is the center of the pressure distribution curve? And this length we know, this length is OA. So x will be what? 1/3 of OA or not? This is the center of the triangle only. So this x will be equal to, this is 1/3 of the OA. What is this OA we found out? This is h by 3 sine 60 degree. 3 sine 60 degree. Now everything we found out. Okay. Now we put in this equation 1. Now we put in equation 1. So write this equation 1. So that is hydrostatic force into this x into this 6 into t. What is this t? If you draw the which weight is suspended, the weight will act downward and the tensile force acting upward. So if it equilibrium, net force y will be equal to 0. So this t will be equal to nothing but w only. Okay. The w is how much given? The w is given you as 60 kilonewton. The w is given you 60 kilonewton. So the hydrostatic force, that is 11.327. This is h square, and this is h by 3 sine 60 degree into 6 into this is 60. So now can you able to find out this h? Can you able to find out this h? Can you able to find out this h? This is coming out to be how much? This is coming out to 4.36. 4.36 HQ will be equal to 360. So this h will be equal to 360 divided by 4.36 to the power 1 by 3. So what is this h? H you are getting, this one is how much? Calculate how much you are getting. This is coming out to be 4.36 meter. Okay. So this is the head of the water at the upstream end of the gate. This is the head of the water at the upstream end of the gate. This will be equal to, this is 4.36 meter. If the head of the water will just exceed this 4.36 meter, what will happen? The gate will rotate about this point O. The gate will try to rotate about this point O. So in order to avoid that kind of failure, that kind of rotation, so we have to keep the head always less than this 4.36 meter. Okay, 4.36 meter. That is the case. Okay, in order to avoid the rotation about this point hinge O point, so the head of the water to be kept less than 4.36 meter. Alisa Agrawal is correct. I think this problem is very nice problem. This kind of problem is real engineering scenario problem. Okay, this real engineering scenario. Suppose there will be twist in some of the book or some of the problem. Here actually what will happen? The weight, self weight of the gate has not been considered. I mean the self weight of the gate, okay, it is neglected in this problem. Suppose in some other question this head will be given to you. Okay, this h will be given to you, and it is asking what is the maximum weight of this gate. Okay, what is the maximum weight of the gate? Because if you see, there is this is center of gravity. Here the weight will act. Okay, and this weight will we have to find out what is the maximum weight of the gate. We have to find out what is the range of this weight. Okay, what is the range of this weight? We have to find out. A similar problem is there in your this textbook, answer textbook. So there you can find out this similar problem. There is also one method. This is one type of problem, type 1, where you have to find out this head. There is another type of problem. You have to find out the weight of the gate. What is the range of this weight of the gate? Okay. So now you have to go to the next problem. So next problem will be, this is very easy problem. Okay, so this is this problem. So a metal gate is there. Okay, a metal gate is there, and that gate is 1.25 meter, 1.25 meter and 6 millimeter thick. Okay, that is a square plate is there, and that weight of that plate is given you as 90 Newton. It is placed exactly at midway in 24 millimeter gap between these two vertical plane surface. So the gap is filled with, now it is filled with an oil, specific gravity 0.85. The dynamic viscosity is given 3 Newton per 3 Pascal second. We have to find out what is the force required to lift the plate with a constant velocity of 0.15. The solution will be there in your textbook. Now I will say you the one easiest way how can we solve this one. The easiest way how can we solve this one. Let me proceed for this one. Let me proceed for this one. Okay, fine. So what is the dimension? Solution. What is the dimension of the plate is given? Dimension of the plate, it is given as 1.25 meter into this is 1.25 meter into this is 6 millimeter thickness. Okay, what is the area of the plate now? Okay, so actually plate will be like this. I will draw the figure, don't worry. So area of the plate will be, this is 1.25 into this is 1.25, that is coming out to be 1.5625 meter square. Okay, 1.5625 meters. So let me draw the figure for you. So this is the two side of this one is given to you, fixed one. In this, what will happen, this is the fixed. Okay, in this the square plate will be there, and this zone, what is the oil will be there, the oil will be there. This is the oil, this oil, and this what will happen, square plate is there. So this is the thickness of the plate. If you see the 3D diagram, to see this 3D diagram, how it is look like, it is look like this, it is look like this. Okay, try to draw, and this thickness, this thickness is given as you as 6 mm. Okay, this thickness, and this is given you as 1.25 meter, and this is given you as 1.25. Okay, now it is pulled by certain amount of force. It is pulled by certain amount of force. What will happen? Now if you draw the, now first of all find out the gap. If the gap you have to find, this is H1 and this is H2. Suppose this H1 will be equal to H2 because it is exactly placed at the midway. So what is this H1 or this H2 will be equal to? Okay, this gap is given you as 24 millimeter. Okay, and this is given you as how much? This is 6 mm. So this is 24 minus 6 divided by this is 2. So this is coming out to how much? 9 mm. This is coming out to be 9 mm. And specific gravity of the oil is given you. The specific gravity of the oil 0.85. Okay, dynamic viscosity is given you as, this is 3 Pascal second, highly viscous, 3 Pascal second, and velocity at which the plate is moving, that is 0.15 meter per second, and weight of the plate is given you as, this is 90 Newton. This is data is given to you. Now I have to draw the free body diagram of this plate. Now I have to draw the free body diagram of this plate. The free body diagram of the plate. So I am drawing the front view. So this is the thickness of the plate, which is now it is pulled by certain amount of force. So what will happen? There is a frictional resistance, viscous resistance will be there, or shear resistance, that is Fr. The shear stress will be created. When there is shear stress will be created, so there is a frictional resistance will be occur at the surface area of this plate, at this area, at this surface area of the plate. there will be frictional resistance will be created. Now what will happen? The weight of the plate is acting downward, the weight is acting downward, and there is a buoyancy force will be created by this oil to this plate. Buoyancy force will be created by this oil to this plate. Now if you write down, the net force at equilibrium will be equal to 0. So what is the force? I can write down this upward direction, the force are considered, this one is a positive. Okay, so this is F. Okay, the force plus this is buoyancy force minus this is 2 times of F of R. Okay, minus this weight of the plate will be equal to 0. So now what is the equation? This F will be equal to, this is 2 times F of R plus this weight of the plate minus this buoyancy force. This is equation 1. Now we have to find out each term, because weight of the plate is given to us. So we have to find out the resistance for shear resistance, okay, viscous resistance, and this buoyancy. Then our job is over. So what is this frictional resistance? Okay, this frictional resistance will be equal to the shear stress into the surface area, or I can this area of the plate, contact with oil, the area of the plate which in contact with the plane oil. What is the shear stress? Shear stress will be mu into this is how much? B by H1. So I am assuming there is a linear distribution of velocity. It is not mentioned, so I have to assume the linear velocity profile. So area of the plate is how much? This is 1.25 into this is 1.25. Okay, so now mu is how much? 3 Pascal second. Velocity is how much? 0.15. And this H1 we already found 9 millimeter. So this is 10 to the power minus 3 meter. Into this is how much? 1.25 into this is 1.25. Okay, so what is this resistance? We are getting viscous resistance, that is we are getting 78.125 Newton resistance force we are getting. Now we have to find out what is the buoyancy force. What is the buoyancy force we have to find out. So this buoyancy force by this oil will be equal to what? Density of the oil into how much volume has been submerged. How much volume has been submerged inside this oil into how much? Into this G. Okay, so specific gravity of the oil is given you as 0.85. So what is the density of the oil? Density of the oil will be 0.85 into this is 1000. So this is 850 kg per meter cube. So this will be how much? This is 850 into how much volume has been submerged. It is completely submerged into in water in this oil. Okay, so this is 1.25 into this is 1.25 into this is 6 millimeters, 6 by 1000 into meter, into this G is how much? This is 9.81. So if you find out the buoyancy force, how much this is coming out to be? 78.17 Newton. This is the buoyancy force by the oil onto this plate. Now the resistance force we found out, the buoyancy force we found out. Now can you put our in this equation 1? So now you put our in this equation, this is 2 times what is this? Is 78.125 plus the weight of the plate is given 90 minus this buoyancy force is given this 78.17. Now what is the force required? What is the force required? This is 168.08 Newton. This is the force required, 168.08. Okay, fine. Now we go to last problem of today's class. I will go to our last problem of today's class. This is let's solve this one. Last problem of today's class. This one. Okay, this is the last problem of the today class. So all chapter problems I have brought for you. So that is I brought for you. So a capillary effect in millimeter of glass tube, 4 millimeter this diameter is given to you. Okay, 4 millimeter diameter is given to you, and wet is immersed in water and it is mercury. The temperature of the liquid is given 20 degrees Celsius, and the values of surface tension of the water is given, and mercury is in contact with air is given 0.0735, the water surface tension, and 0.15 Newton per mercury is given. For mercury is given 0.51 Newton per meter. The contact angle of the water is given water glass, and mercury is given theta. The specific weight of the water is given to us. This is 9790 Newton per meter cube. So what is the, find out what is the capillary rise? Very easy question, last problem. So very easy question for you. Okay, so this is the last. Now we have to find out what is the capillary. See, in this, like this question only, it will come in your exam. So you will expect like this question. So the solution. Okay, so diameter is given how much? Diameter of the capillary tube, this is 4 mm given, 4 mm given. So I can, this is 0.004 meter. Okay, and the surface tension at 20 degrees Celsius, that is given for sigma water is how much? So water glass surface tension, that is 0.0735, this is Newton per meter. Okay, and surface tension for mercury is given to you as, this is 0.051 Newton per meter. What is the specific weight of the water is given to us? Specific weight of the water, this is 9790 Newton per meter cube. So we have to find out what is the rise or depression. We know for rise or depression or fall, we can, whatever we can say, rise or depression, the head of the fall or rise, that is 4 sigma cos theta divided by rho g d. This class is for your practice. Okay, you practice as much as numerical, so you will get a confidence in this subject. Fluid mechanics is only problem oriented subject. So we have to find out first capillary rise in water. Capillary rise in water. So this H will be equal to, this is 4 sigma cos theta by, this is rho g, I can write down this specific weight of the water, into this is d. So here for water, you remember this theta will be equal to 0 degree. Okay, if it is given, otherwise you should take cos theta will be equal to 0 degree. So this is 4, and sigma is given 0.0735 into this, it is cos 0 degree divided by, this is specific weight of the water, this is how much? 9790 into this is 0.004. Okay, so this capillary rise we are getting 7.51 millimeter. This is rise. Okay, this is capillary rise. So now I have to find what is the capillary fall. Now I have to find, this is very easy question. What is the capillary fall in mercury? What is the capillary fall in mercury? H will be equal to 4 sigma cos theta divided by, this is rho g, this is mercury, into g, into this is d. Theta is given how much here? Theta is given 130 degree. Now this is 4 into sigma is given as your 0.051 into this is cos, this is 130 degree. Their specific weight is not given, so you would just density of them 13,600 into this is 9.81 into d is given how much? This is 0.004, 4 millimeter is given. So if you find out the depression, we are getting as 2.46 mm. This is the fall. This is the fall in height. Okay, fall in height. Now I am giving you an assignment to you, so try to solve this question at your home. Okay, try to solve this question at your home. So this is the question to you. Please write this question. So this question is given to you. Okay, So it shows a rectangular sluice gate is there, 3 meter wide and 4 meter long, hinged at A. It is kept closed by weight fixed to the gate. Solve by yourself. But apply the concept. If you are not getting, then ask me. The total, this is a real engineering problem. The total weight of the gate and weight fixed to the total weight of the gate and the weight fixed to H, which will first cause the gate to open. Okay. The center of gravity of the weight gate is given G. It is asking to what is the find the height of the water H, which will first cause the gate to open. Okay. So what is the picture? If you want to see the picture will be this one. This is the case is given to us. So we have to find out this height of the you have to find out what is this height. Okay, so take it is an assignment for you. So take this as assignment for you today and try to solve this question. This is an assignment for you. Okay, assignment. And after solving, you just send this your solution to this BR, and that BR will send the solution to me. Okay. So thank you all. So today we have faced lots of problem during this internet connection. So I hope tomorrow onwards, if it is not if there is no problem, there is not problem in buffering. Okay, a little bit internet connection is slow right over here. That's why we are getting a problem. But tomorrow onwards, we will not get any problem. Okay. So thank you, Balram Sau. Janmanjay Das. No, it is not buffering right over now. It is coming clear. Is it coming clear na? Is it coming clear? Now the video is coming clear or not? Is the video is coming clear now? See, one example I am giving to you. If some problem will happen now, never be afraid. Just keep patience and try to resolve it. Today there is a problem, buffering problem was there. Many students are watching me live. Okay, if I will stop immediately, many students will think negative will they will decide. So I keep on trying. And lastly it is resolved. Okay, so try to be part of the problem. Means always try to solve the problem. Don't think that the problem will be big. You will be afraid. Definitely the problem will be resolved one day. Okay. So thank you all. So today the attendance password will be. This is let me I forget that one. Okay, found. So the password will be 105. So this is 105. The password will be 105. Okay, and please like, subscribe and share my video. Okay, my video to all your friends. So thank you all. Okay, thank you. Okay, tomorrow we will meet at new time. I will let you know tomorrow. I will let you know when I will have a class. Okay, let you know tomorrow. Thank you.